Talk about how to word that final conclusion. This chart is going to be your best friend in this chapter. So you first got to decide, does that original claim have a condition of equality? If it does, you're going to follow the chart this way, and then you've got to determine whether you reject or fail to reject. And then that's going to start your wording for your conclusion. Same thing here. If you ended up going the no route, does the original claim contain an equality? If it did not, if it was greater than or equal to, then you would then decide if you reject or fail to reject, and then you would phrase that final wording. So there's really only one of four ways you could phrase that end. So let's look at how to use this chart. The next slide is basically the same chart, just written out a little bit easier. I like using the flowchart over here because I think you can see it a little better. So let's look at a few examples. I'm going to call these 1, 2, and 3. Number 1, the original claim says the percentage of blue M&Ms is greater than 5%. So they're giving us that alternative hypothesis. And the conclusion was the fail to reject. So if we look at this guy, let's go back to that flow chart. Does the original claim contain an equality? The answer is no, because it says greater than. And we ended up failing to reject. So we would say there is not sufficient evidence to support the claim that, and then we insert that claim. So our final answer would say there is not sufficient evidence to support the claim that, and the original claim was the percentage of blue M&Ms is greater than 5%. So you can see how we're taking that piece from the flow chart and we're putting that original claim together to get that final conclusion. Let's look at 2. The original claim says the percentage of on-time U.S. airline flights is less than 75%. So that less than 75% is the alternative. So this ends up being a left-tailed test. We're going to reject the null. So let's go back to our chart. Does the original claim contain an equality? No. And then we were told to reject the null. So we're going to start out with this statement. There is sufficient evidence to support the claim that. The only difference between these two is that one little word there, not. But that not makes a big difference in that final answer. So our statement's going to say, there is sufficient evidence to support the claim that, and then we're going to insert that claim about U.S. airlines. So there is sufficient evidence to support the claim that the percentage of on-time U.S. airline flights is less than 75%. So all that's based on what we've got from that chart and whether we're going to reject or fail to reject and what's going on in that original claim. So then let's look at 3. The percentage of Americans who know their credit score is equal to 20%. So they have given us the null hypothesis here. P is equal to 0.20. So the alternative would be not equal to 0.20. Okay, but because this is an equality statement and we're going to fail to reject, so because this is an equality statement, we're following this side. And then we were going to fail to reject. So this is how we're going to phrase this. There is not sufficient evidence to warrant rejection of the claim. So there is not sufficient evidence to warrant rejection of the claim that the percentage of Americans who know their credit score is equal to 20%. So you can see how we're putting that original claim with that piece from that chart. The last thing we need to talk about in this introduction to hypothesis testing are the errors. So there are 2 types of errors that could happen, a type 1 error and a type 2 error. The type 1 error is the decision to reject the null when the null is actually true. And the type 2 error is when we don't reject the null and the alternative is true. So I don't want to spend a lot of time on errors. I just want to talk about the fact that they do exist and maybe look at one example. So the probability of making a type 1 error is always going to be alpha. That's always going to be decided by the researcher before sampling data is ever collected. What kind of level of significance am I looking for? And it really depends on the problem. We're going to see some in the next few sections where we're using varying levels of significance. Sometimes it's going to be 5%. Sometimes it's going to be smaller. Sometimes, it could be 10%. Beta is a little bit more complicated to compute. Usually you have a software that will help you compute that. That's the probability of not rejecting the null when the alternative is actually the true statement there. So take a few minutes, read through the next couple of slides talking about type 1 and type 2 errors. So when we talk about type 1 and type 2, and I'm just going to talk about one of these. Let's look at that first one. So here's the scenario that's going on. In 2008, 62% of American adults regularly volunteered their time for charity work. The researcher believes that this percentage is different today. We want to talk about what would the type 1 and type 2 error look like. So the type 1 error remember, the type 1 error is the probability of rejecting the null hypothesis when it's actually going to be a true statement. So in this case, the type 1 error is made if the researcher concludes that that proportion is not equal to 0.62 when the true proportion is actually 0.62 or 62%. So if we were to look at those hypotheses, that's what the null would look like. If he believes that it's different today, then he's saying that it's not equal to. So the type 1 error is the probability of rejecting the null when the null is actually a true statement. So what he did is concluded that it's not equal to 0.62 when it actually is equal to 0.62 because that null is a true statement. So the type 2 error, remember that's the probability of failing to reject the null when it's false. So type 2 error is made in this case if the sample evidence is leading the researcher to believe that the current percentage is still 62%. So he's failing to reject the null here. Okay? So he's saying it is 62% when actually it's not 62%. It's going to be different in some way. We don't know greater than or less than 62%. We just know it's not equal to 0.62. So then we could go through and we could analyze part B2. I'll let you have some time to read through these slides and make sure that those make sense. So in the next section, we're going to start talking about testing the claim about a proportion and look at the process involved with that.